The median salary is 80,500. Which of these is the best approximation for the mean? So the best way to do this one, this was a repeat. You had this one also on your statistics practice test way back when. If you look at the shape, well, how can I describe that shape? Skewed where? Yeah, skewed to the right. You can say positively skewed because that's where the tail is. We do it based on the tail. And we learned that the the mean is always going to be on the side of the tail. Mean and median are both measures of center. The mean and the median are both supposed to be close to the middle. But the mean is always going to be on the side of the tail. So if we were to say that our mean and median are somewhere around there on the middle, the mean is always going to be closer to where the tail is. For instance, those EOC scores that we were just talking about, right? I haven't seen a histogram of my scores, but it looks like our scores would have a right side tail. The median here was much less than the mean. And the reason why is because the mean is more affected by the extremes. We had two students here that scored very high amongst their peers, and that kind of artificially brought up our average, but the median wasn't as great. So the mean is always going to be on the side of the tail. And they've already told you that the median is 80,500, then the mean would have to be greater than that. So it can't be this, it can't be this, it can't be that. What's the only one it could be? You don't have to go adding all of those up and trying to find the mean that way. That would take forever. If it was a free response, maybe you'd have to, but that's not what the question was intended for. It wasn't intended to be a free response. No questions there. A survey asked 100 students whether or not they like two sports. Okay, so what is the relative frequency of students who like tennis? Okay, so here my sample is just students, and they told us there was 100, but if you wanted to check, you could add those up. The point is that goes on the bottom, and then how many kids like tennis? Yeah, it's these two. Likes tennis, yes. 30 out of 100. These are the same questions on the retake. Not all of them, but it's the ones that were missed the most. Yoshi plans to open a savings account with $2,000. He compares the savings accounts plans at two banks. Each bank offers an annual interest rate of 8%. Bank A compounds the interest monthly, while Bank B compounds the interest annually. Which of the following function pairs can be used to find? So they're not even asking you to find an actual money amount, just what would be the correct formulas. So when we're compounding, 8 is a percent. Bank A compounds monthly. What's the number that we use for compounded monthly? It's 12, and that 12 needs to be, you have to divide the rate by it, but then on the outside, you multiply the exponent by it. So looking at all of these, well, it looks like the only one it can be is A, but let's look at it closer. Initial amount, 20,000, good. 1 plus, because you earn interest, here's the 8%, and there it is dividing by 12, and here the 12 is multiplying by the time. So that one's good. But then just to verify, there is a Bank B, and Bank B is just annual interest. So what would be my growth rate? What would be the growth rate if we just compound annually? All it is really that 1 plus the 0.08, which they've already accounted for by that. Same problems are going to be on. Doris decided to start a stamp collection. She hopes to triple the total number of stamps that she has in her collection each year. She has 3 stamps when she starts. This, which sequence represents the number of stamps she will have in her collection each year? Okay, so she started with 3. And it looks like all of these agree with that. And then now, which of these have each new number, each subsequent number is tripling the one before? Well, what does triple mean? How about that? Times 3. So which of these is times 3? This one is plus 3. This one, adding 6. That's adding 6. The other one down here, times 3, times 3, times 3. Oh, wow. So, yeah. A and D are close because 3 times 3 is 9, 9 times 3 is 27. But then after the 27, what's 27 times 3? Yeah, 81. So it has to be D. And then 81 times 3 is 243. Didier will go camping for a summer vacation. It costs $5 to rent a tent, and the campsite costs $3 per night. He uses the equation y equals 3x plus 5 to figure out how much money he will spend. What do x and y represent? Okay. So y is the one that's by itself, and then they even tell you this is the equation is meant to figure out how much money he will spend. So y is going to be the amount of money he's spending in total. And if he's spending $3 per night and multiplying that times x, what do you think x represents? The number of nights. So x is not the cost of a tent. X is the number of nights, and y represents the cost of renting a tent. No, it's not just the renting a tent. X represents the number of nights, and y is the total cost. That one seems good of the camping trip. X, yeah, and it's not D either. So it's what is the common difference of this arithmetic sequence? All right, so they've already told you that this is arithmetic, so we know that there's a common difference. So even though we hate fractions, if we know that the difference is common, we don't have to test each one. We can pick any two. I'm guessing you would rather not deal with, even though it's not that crazy, but I'd rather not deal with mixed numbers. So you can always jump to the one on the right and subtract the one before. If you want to figure out what you're adding or subtracting to go right, you go forward and then subtract the one behind it, which is 2 over 4, which is 1. Each of these are going up by 1/2. Common difference. Right, Caleb? You go back to Duke if you didn't want to sign a pro contract. You're still eligible. A farm agency staff track the amount of rainfall that farms of similar size and crop, blah, blah, blah. Okay, so it's a scatter plot. Which conclusion about the relationship between the two variables is most likely? So if we're just looking at the choices, strong correlation, not correlated, strong correlation, weakly correlated. Okay. If there is a correlation here, would it be a positive or a negative one? A positive, because as rainfall is increasing, so is the crop yield. Because look at the direction there it's going. It's going up and to the right. So both of them would have to be increasing. Now the question is, how strong is that? It doesn't look all that strong. It does kind of tend to be going in the same direction. I would say that's moderate at best. But let's see what options they give us. We know it's not going to be any of the things with the decreased rainfall. It can't be C or D because everything here is increasing. So it's either going to be increased rainfall is strongly correlated with an increase in crop yield, or increase is not correlated. See, I wouldn't say not correlated. There appears to be some type of a correlation there. If it would have said now weakly correlated, oh man, now I got a kind of a decision to make. And honestly, I wouldn't even, because I don't consider that to be strong, but I also don't consider it to have no correlation. No correlation would mean that the points are just completely randomly scattered everywhere, and that you definitely can't say. So of the two, it'd have to be A. I guess maybe the way they get away with it is because they don't say that it's definitively true, but they say it's most likely true. And Len, are you okay? You were so excited when you got here. Reese, stop being so boring. You're boring, and Len. Bruce plans to invest $10,000 in either a mutual fund or a high yield savings account. The projected value of the mutual fund after T years is okay, blah, blah, blah. The value of the high yield savings account over 3 months is given in the table below. Which option will give him the higher annual return on his investment? All right, so let's see. The projected value over T years is given by the function and the value over 3 months. And he wants to know what's going to give him a higher annual return on his investment. So annual return is just 1 year. It doesn't say it says for T years. All right. So I guess what we would have to see here is, because if one of them is increasing monthly, is what's the annual percent on the mutual fund? Based on the growth factor there, what's the annual percent? Yeah, he's gaining 12% on his money each year. 12% each year. Now the gain on the on this high yield savings account, we don't know for sure because they only give us 3 months of it. Okay. Now what is it? How does it appear to be increasing every each month? Is it 1%? Okay. Yeah, it looks to be exponential, but if you're not sure, divide 10. 10,100 divided by 10,000. So, and N says 1%, and we trust. So, all right. So how would you do this? So if it's gonna go up 1% every month, that would make you think it's gonna be let's write the function. So the amount over some time is equal to 10,000, which is what he's starting with. Okay, but now he's getting 1% on his money, but that is happening 12 times every year. It's multiplying by that by 12 times in a year. When you multiply an exponent, that's like doing a power of a power. So I can use my properties of exponents to say that this is 1.01 to the 12th. I can basically bring that 12 into the inside and then have it to the t power. Because the benefit of doing that is that now I can compare apples to apples. Since both of these had a 10,000 in the front, and now by writing it this way, they both have just a t on the exponent. All I would be doing is comparing the growth rates. And the power property of exponents allows me to do that. When I have a power of a power, what am I allowed to do? When I have a power of a power? Multiply them, which is what is written here. I would just rather write it this way. So the question is, what is 1.01 to the 12th power? What is 1.01 to the 12th power? 1.1268. And that, I guess that's high. That's slightly higher than. That's slightly higher. Um, wow, you know what? I wonder now if I have that right on the. Let me see what the answer was on the actual test. It should be B then, right? It's because it's slightly better on the high yield savings account. I had it wrong. All right, I'm gonna have to go back and I'll just regrade it because that one is wrong on my key. The answer should be B. Huh? Here I had it as A. I would have thought it would have been C maybe by mistake, but I don't remember if I got these from an answer key or if I did them myself. But which option gives them the higher annual return? Yeah, it's very, very minimal. But on Anne's calculator, she's getting 1.12 something or other, whereas here it's just 1.12. So it's slightly better on B. So it's not going to change your grade all that much. It probably will not change your overall grade, and on the classwork grade, it might change it a couple percentage points, but not much. But just to be fair, I'll go back and change it. I'll have that up by tonight. Any questions there? Do you understand why when I did I delete it already? 1.1268 is greater than I'm just saying 1.12. It isn't a lot greater, but it's a little bit greater. So trying to make sure that my logic is correct. Counting in months. That was my yearly. And can you check what's 0.1268 divided by 12? Wondering if they intended for it to be the same. I mean, I think my logic is sound here because we're going up a percent every month, and that's compounding 12 times a year. So my logic is supposed to be good, but then it should work vice versa, no? Shouldn't it then work try 0.1268 divided by 144. Yeah, 0.1268 divided by 144. Then if that's the annual, if that is indeed the annual, which is what I'm getting, then I should be able to put it in backwards. I'm just trying to put that in backwards, and it should work. You know, where the 0.1268, I should be able to divide it by 12 like it goes compounding monthly. So, okay, how about this? Let's just do it manually then. Sorry, we have a little bit of time. Let's just do this. Put in for 1 year. Um, if I make 12% 1 year, or put let's put 10,000 times 1.12. What's that? Is that 11,120? Okay, 11,200. Okay. So then now let's do this. Put yeah, it's gonna have to. Yeah, I have to be right there because that's all I'm doing is I'm multiplying. Put 10,000 times 1.01 to the 12th power. Yeah, yeah, it has to be. All right, so it has to be. All right, sorry about that. I just wanted to make sure I'm all right. Look, it has to be A because sorry, B. Sorry about that. B, yeah. The savings account. In the geometric sequence shown below, A sub n represents the nth term in the sequence. What is the recursive formula of the sequence? All right, so what's the common ratio? Those are all exponential, right? Or they tell you it's geometric. What's the common ratio? So which one here has that every number is 3 times the number that came before it? Every new number is. It doesn't give you. It doesn't tell you what the first number is, but every number is 3 times the number that came before. If you have any questions, stop me. The president of a community college hopes to increase the school's enrollment each year. The number of students enrolled at the school during the year when the president began this initiative was 4,000. She listed the approximate number of students she hopes to have enrolled each year in the table below. Which is the closest to the rate of increase that the president of the school hopes to have each year? Okay, well, they're saying it's a rate of increase. So that leads you to think that this is exponential, it's geometric. So now just go divide. What's 40 divided by 4,000? 1.0. Oh, okay, yeah, all right, sorry, I got you. That's times 1.01. So now what's 4080 divided by 4040? 1.0099. Okay. How about let me make sure I read this right. Here. So what is the closest to the rate of increase that's supposed to happen here? All right. What's 4121 divided by 4080? 1.01. And then what's 4162 divided by 4121? 1.0099. All right, so notice how I said what's the closest, right? So the thing is, if we were to round this 1 point, even though it requires rounding, if we were to round these 1.0099s to get rid of those 99s, that would round up to 1.01. So meaning each year it's going up about 1%. 0.01 is let me say 1%. Find the average rate of change for the following graphs over the given interval. Okay, between 1 and 2, that's already marked for you. I mean, you can do slope formula, but we've done these so many times by now. You should be able to tell that that thing is rising 2, the rise is 2, and the run is 1. And what direction is it going? What type of slope goes up, left, down, right? So that's going to be -2 over 1, which is -2. On the Google form, just type in -2. If you put those points in the slope formula, you get the same thing. On this next one, I'll have to do that. Find the average rate of change. So they give me the x's. I have to come up with the y's. Why do I not have to plug in the 0 to figure out what the y is going to be? It's the y-intercept. When x is 0, it's the y-intercept, and that's in standard form. But for the -2, I have to plug it in. I showed you how to do it synthetically. You can do it traditionally if you want. Drop a 2, -4, -3, +6, 7. When I plug in a -2, I get 7. Yara, did you also get 7? Slope is 7 minus 1 over -2 minus 0, which is 6 over -2, which is -3. That's what you would type in on the Google form. What is the 12th term in the sequence? Okay, what type of sequence does this appear to be? Huh? No, yeah, it is geometric. It is times 2 is a common ratio. So you have two options. You can find it recursively if you want. You can keep on going times 2, times 2, times 2 until you figure out what the 12th number is. Or you can just use the explicit definition, which says that any number in a sequence that is geometric is the first number, which is 2, times the common ratio here, which also happens to be 2, to the power of n minus 1, which in this case the n is 12. So that's basically the same thing as saying 2 times 2 to the 11th, or since it just happens to be that the first number is the same as the common ratio, if I multiply 2 times itself 11 times, but then multiply it by 2 again at the end, well, I'm really just doing 2 to the 12th. So what's 2 to the 12th? Ready, set, calculate. 4096. Find an explicit formula for this. All right. So what type of sequence does this appear to be? How do you know it's arithmetic? Because of the +4 at the end is the common difference. So the implicit definition would be the first amount, which they tell you here is 17, plus that common difference times n minus 1. They might leave it like that, but they do not. So I did this a couple of times when I first started to you. It's very common for arithmetic sequences that they distribute. So +4n minus 4, and then combine. So we get 4n plus 13. Find the first term of a sequence. Okay, yeah, this is a phone one. There might have been nobody that got this one right. I think it was one of them that nobody got right. This might have been it. So, because this has a common difference, I know it's arithmetic. Okay, and if they tell me that the 20th number, there's actually two. You can even. Actually, no, you wouldn't. You wouldn't be able to. You have to do it this way. If the 20th number is negative 16, then I can say negative 16 is the first amount, which I do not know. Let's just call that A, plus the common difference, which is negative 4. But then instead of putting n minus 1, I would put 20 minus 1, because that negative 16 is the 20th number. 20 minus 1 is 19. What's 19 times negative 4? Negative 76. Add 76 to both sides. The first number would be 16. Then these last couple that are just quick, odd, even, or neither, remember to change. I evaluate f at negative x. So negative x to the third minus negative x. Change all the x's to negative x's. What is negative x to the third power? It stays negative. A negative to an odd stays negative. What's a negative negative? Do they stay the same? Is this the same as the original? No. So it can't be even. Did all the signs change? Yes. So this is odd. Evaluate f at negative x. Negative 7 times negative x is 7x. Did it stay the same? No, the first one was negative, this one's positive, but they're not the same, so it can't be even. Did the signs change? Yeah, there was only one sign and it changed. So this is odd again. And finally, the last one. I think there was 28 yesterday, so I'm doing 18 out of 28 for you. Let's evaluate f at negative x. 2 times negative x to the fourth minus 3 times negative x squared minus 6. What's a negative to an even? No, it's positive. A negative to an even is going to be, so this just stays 2x to the fourth positive. A negative to an even power is again positive, but I have this negative 3 in front that's going to keep that negative. Because this becomes positive, but when you multiply it with a negative, it stays negative. But then the negative 6 just drops. Did everything stay the same? Yes, it did. This has to be even. If you didn't already notice, I'll let you in on a little secret now since we're kind of already done with this. All of these problems that I put in all these last practice tests for the final for even and odd are the same ones we did that day with the activity. Remember that I gave you a handout that had like a bunch of like a grid? It's the exact same ones. I just scattered them around. Any questions for me? Yes, ma'am.
Did you add
For number C? Yeah, you want to see your? I can go with it. You want to go over it individually? You want me to show you what you got? Okay, yeah, I average it. It's an average. Because I would love to give you the higher of the two, but then people wouldn't take the one in class seriously. They would blow it off and then just do it later. So I have to try to put something in for you to take it seriously the first time around.